Hi, and welcome back. Okay, so let's take a look at this. Let's go ahead and just start writing a class. So let's write this language class, and we're going to create basically class attributes. So major equals 3, minor is going to be 7. So this is like a language, and this is like the version for the language. And so revision, and we'll make that equal to 4. Okay, and then the full version, we're going to basically make it a concatenated set of the major, minor, and revision as strings. So I'll do the interpolation this way this time. I'll use the format simply because then these major, minor, and revision are going to stand out a little bit more. So this is absolutely fine. This major over here is a symbol, but it's inside the body scope, so it's going to find it in that namespace. So it's going to use major equals 3, minor will be 7, and revision will be 4. So now if we do this, we can look at language.full, and you'll see we get 3.7.4. Now with functions, however, if the attribute is pointing to a function, the function's scope is not nested within the class scope. So this means that we cannot reference class symbols that are inside a function without telling Python that it has to look in that particular class. So let me show you what I mean. Let's go back. Let's take this. I'm going to take out the full over here. And now instead we're going to write, let's say, a property. Now a property is a function. So we define the function, and it's going to be an instance function, so it will be aware of self. And here we're going to return what we had before. So I'm just going to return this, like so. But now, of course, I have to say self.major and self.minor and self.revision. So now I can create an instance, let's say, of language, and I can look at the version. And we get 3.7.4. That works fine because we used self. Now, we could have done a class method. So if we're going to do a class method, let's call this the class version method, then we're going to receive the class as the argument, and we're going to return now the same thing, except now we have to tell Python where to find major. It's not in self, it's in class. So we're just going to replace that with class. And of course, we can also do this with a static method. So if we use a static method, let's call it static version. And of course, we get no arguments here. And then here, I'm going to return that. But now, of course, I don't have class or self. I have to tell Python where to find major. This would not work. Major is not going to be found because it is not in my global scope, and Python doesn't look in the body scope for that. So I have to tell it specifically to look at the language.major, like so. And then I need to do that for all the other ones as well. So now that we have that, once I fix my typo, then we can do language.version like before. We also have the, let's fix that to static version. We can now call the class version. So now I can say language.class version. That works correctly. And of course, we can also call the static version, and that works perfectly well as well. So think of this, let's say, as basically doing it this way. So let's go ahead and let me take this over here. Let's come back down here. I'm going to remove this, and I'm going to define a function external to the class. Let's call the function full version, and it's going to return this. Now, of course, I'm outside the class. At this point, I already know that I expect that I have to specify which class I'm using. So I'm going to use language.major, language.minor, and language.revision. Okay. So now if I call the full version function, that will work just fine. So now let's go back and let me redefine the class language. Oops. Over here, now that I have this full version defined, okay, and I'm going to say here that the full version, that the version is equal to full version, like so. So now I have a class attribute called version that is pointing to this function, right? So now I should be able to do this, language.version. Now what is it going to do? What is language.version? Well, if we look at the language.version, is it the same as full version? The answer to that, of course, is true. It's the same thing, right? This symbol is just pointing to this function, which is sitting inside my module, not inside my class. However, it is callable, so I can go ahead and call it. And when I call it, you can see it essentially ran this function over here. And so that made sense, right? It picked up major from language. So now let me go back to this. So I'm going to go ahead and do that. And then I'm going to take the full version. And I'm going to redefine what full version is. It is basically going to be major, minor, and revision, but without the language, right? So now, if I was to run full version at this point, right? If I try and do this, well, that is not going to work. I'm going to get this exception that major is not defined, right? It's not defined and it's not in the module. And of course, if I call it from the language class, because remember again that the language version is the full version, right? It's the same thing. It's the same function. So if I call that from here, I'm going to get the same exception, right? Major is not defined. And this is no different than if I had done this. So now let me go ahead and copy paste this over here. And here I'm going to say def version. So I'm going to define the version here. And here maybe I'm going to make that into a static method. But I don't have to. I could leave it as an instance method and pass in the self. Okay, that'd be fine too. And now I can go ahead and implement this over here. So we can take that out. So now if I make an instance of language and I call language.version, you'll see that I get the same exception. I get that major is not defined. So yes, this function is defined inside the class, but this doesn't mean that there's no visibility from this function. There's no visibility of the namespace of the class body, just like we had over here. It's no different. Now, of course, with nested scopes, you know, things work as usual with those functions. So this means that the following could happen. Let's say I define major in my module now. So major, minor is going to be defined in the module and revision as well. So revision equals that. Now I'm going to create a function called genClass, and it is going to redefine in its own scope major, minor, and revision, like so. And then I'm going to define a class inside. So now I'm nesting things, right? I'm starting to get nested scopes. And here again, I'm going to go back and redefine again for this class the major, minor, and revision. And let's go ahead and make that 3.7.4, like so. And now I'm going to write a class method. And the class method is going to basically receive the class, and it's going to return. And again, I'm just going to interpolate three things. I'm going to interpolate what? Well, this time I'm going to interpolate major, minor, and revision, like so. Now, which one is it going to see? Which scope is this function actually contained in? It is contained in the scope of genClass. Remember, it's not contained in the class body scope. It's contained in the containing class. Well, where is language contained? The class is contained in genClass. So it's going to be in that scope. So major is actually going to be referring to major over here. And now what I'm going to do for the function is I'm going to return the language class. Okay? So it's basically, this is like a class factory. Now let's go ahead and create this class. So I'm going to call the genClass function, and the genClass function is going to return to me this class over here that contains this function. And if I call class.version now, what do we get? As we expected, we now get 0.4.2. It saw that over here. Now, if I did not have that, then where would it find the values? It would find them at the module level. And so here you can see I get 0.0.1. Now also something I want to observe is that this function over here is basically closing over major, minor, and revision, right, from the outer scope. So this makes this function over here a closure. It is actually, in fact, a closure. And we can see that, if you want, we can import the inspect module, and then we can say inspect.getClosure variables, and then we can just retrieve it from now this class, right? And then we take the version, which is the function, this class method, from this class. And you'll see that it is indeed a closure. It has these non-locals, major, minor, and revision. So I want to show you another example of some unexpected behavior. Actually, this was something that a friend of mine brought up, and there was some puzzlement about it. And I want to explain what's going on here because it's exactly related to what we're looking at right now. So let me go ahead and just clear. So I'm going to restart basically my kernel, which means that at this point my globals don't contain anything, right, other than the built-in stuff. But you can see I don't have anything left from these classes and, you know, major, minor, all that is gone from my current scope, from my current namespace at my global or module level. Now let me go ahead and create a module variable. So a global variable, let's call it name. Now I'm going to define this class, my class, and I'm going to make name a class attribute in here. I will make it, let's say, Raymond. Now I'm going to say list underscore 1 is equal to name times 3. And then I'm going to say list underscore 2 is equal to name dot, let's say, upper for I in range 3. And you don't actually have to call upper. You can just say name for I in range 3. Right? So we would expect maybe that this is going to be the same thing, list 1 and list 2. I'm also going to write a class method. So let's write this class method and let's just call it hello class. And then we're going to say return, and we'll say something says hello, and we'll format that with just name. Okay. So at this point, if we run this class, if we go ahead and we call myClass.hello, what do you expect is going to happen? Well, where is name going to come from? Is it going to come from the class body? No, it's going to come from whatever scope encloses my class. In this case, it will find name in the global scope. So when I do that, I get that Guido says hello. All right, so that is something that you should have expected now. Now let's go ahead and take a look at my class.list underscore 1. What do you expect that is going to contain? I'm referencing name inside the scope, right? Inside the body scope. So it should be using this name over here. And in fact, when we see what we get Raymond 3 times. Okay, so that's great. Now what about list 2? Well, we're referencing name over here, and we're inside the class scope, so we might expect this name to come from the class. So let's go ahead and see what we have. So we'll say myClass.list2, and we get Guido 3 times. What's going on? Well, you have to remember, this is a comprehension. A comprehension is actually nothing more than a thinly veiled function. This is something that I've covered before. Because it's a function, where is its scope contained? It is contained in the outer one. So it is contained in this case, in the module scope, all right, of the Jupyter Notebook. So this is why this name over here is actually referencing this one. It's the same thing as when I had hello with this name that was basically seeing this one. It bypasses the class body. This does the same thing because comprehensions are functions. So whether you're using a generator comprehension, dictionary comprehension, list comprehension, set comprehension, it doesn't matter. They're all functions. They're all going to behave the same way. All right. So this was the source of the puzzlement, and this is the explanation of why that's happening. All right. Thanks for watching, and I'll see you in the next video.